Okay, welcome back to our video lecture and our second part of Unit 2, which is on intelligence and problem solving. We are going to be doing modules 2.8 A, B, C, D split into part 1 and part 2. So today is going to be part 1, and this is about different types of academic testing. The main focus on here is going to be intelligence tests. So when looking at academic testing, there are two overarching types of academic tests. There's achievement tests and aptitude tests. I like to remember the difference with the word aptitude, underlining the letter P. Aptitude tests predict future success. So aptitude tests are things like the ACT and SAT, which are supposed to predict how successful you're going to be as a college student. And they tend to look at, they say that they predict your grades that you're going to have in college. So that better you do on the ACT and SAT is correlated, so they say, with the how well you do on your college grades. In contrast, achievement tests are tests that measure what you already know. So things like the AP exam or unit exams, any tests and quizzes you take that tests you on what you've already been taught. When we look at intelligence tests, we are going to focus on intelligence tests being an aptitude test. These are to predict your success as a student and in life. So they're technically an aptitude test. With both aptitude and achievement tests, however, in order for it to be a good measurement, whether that be measurement of prediction or measurement of achievement, tests need to be both reliable and valid. And ideally, especially for aptitude tests, they need to be standardized. So reliability versus validity, there's kind of a few things that go with that. Overall, reliability just means, do you get the same score, the same outcome every time you take this test? And validity overall means, does this test measure what it's supposed to be measuring? So I like to think about the difference of reliability and validity by thinking about a scale. So if I had a scale in front of me and I got on the scale and it said I weighed 75 pounds, got off the scale, got on the scale, said I weighed 75 pounds, got off the scale, got on it, said I weighed 75 pounds. That scale would be reliable because that is giving me the same score every single time. However, when it comes to validity, that scale would not be valid because that's not an accurate measurement of my weight. I am in no way, shape, or form 75 pounds. So I'm getting the same score every time. That's reliable. Validity, is that test actually measuring what it's supposed to? So that's kind of big picture difference of reliability and validity. If we break it down into types of reliability, there's test-retest and split-half reliability. So test-retest just means exactly what it says. You give the test, and then you give it again, and you give it again. You give that test multiple times, and do they get the same score every time they take it? If so, that test is reliable. Or you might do split half, where you might take all the odd numbers and get a score, and all the even numbers and get a score. Are those two scores equitable or similar? If so, again, that test can be considered reliable. In contrast to that, validity, again, validity is the measurement. Does this test measure what it's supposed to measure? So there's content, construct, and predictive validity. So content validity, this is, does the content of the test measure what it's supposed to? So this is really, works really well for like achievement tests, right? Did that test on memory actually test you on the content memory? When you take a driver's license test, does that driver's license test actually measure you for the knowledge that you gained about the rules of the road? So content is just, does it measure, is it testing you? Is it measuring the knowledge you've obtained about whatever topic it is that you were supposed to be tested on? Construct, this type of validity asks, does it measure the abstract concept or the construct that I'm trying to measure? So this works, we look at the validity, the construct validity of like depression scales. If I gave somebody a depression scale to measure whether or not they meet the criteria for depression, does that scale, does that test actually measure that abstract concept of depression? Or if I give a test that's supposed to measure your self-esteem, does that test actually measure that concept of self-esteem or depression? Finally, there's predictive validity. And as you can infer, predictive validity works very nicely with aptitude tests. The question again, does this test actually predict your future performance? If you are taking a test that's supposed to predict how good you're going to do in college, does that test actually predict how well you do in college? If that test is supposed to predict how good of an electrician you're going to be, in order for it to have predictive validity, are you actually, when you do better on that test, are you actually a better electrician? And so when we looked at the predictive validity of IQ tests and SAT, ACT, and the GRE, which is like GRE is like the equivalent of the ACT only for grad school, we find that IQ scores correlate to school performance for ages about 6 to 12 at about plus 0.6. Okay, so remember, correlation coefficients, those are scores, anything between -1 and +1. So they find a positive correlation of 0.6 when you're the ages 6 to 12. When they look at the SAT's ability to predict your first year of college success, we find that it is lower. The approximate correlation coefficient for SAT and the correlation to your college grades your first year is about a 0.5. And the GRE, similar to the SAT, only for graduate school, is a correlation coefficient of about plus 0.4. So what we see is that as we get older, the predictive validity of tests are actually decreasing. The final thing that we need to do, especially with aptitude tests, is help to make those tests better, is to use a process called standardization. And what this means is to make sure that everybody who takes that test, so let's talk about intelligence tests or ACT or SAT, every single person who takes that test is going to take it in the same way, with the same instructions, with the same time limits, with the same conditions. It also creates a scoring system. So it looks at how can we take your score and compare it to a larger group of people that this test has already been given to. So the goal here is when you standardize a test, you're ensuring that the test is fair and consistent for everyone who's taking it. So before you even give the test, you need to standardize it first. You need to first give it to a large group of people, figure out how each of those people score. Then you need to make sure you create time limits, conditions, instructions, directions, scoring systems, so that when you give it to the masses, everybody has a similar experience, and then each individual's score is compared to the score of that standardized group of people that you gave that test to earlier on. So that's why, like when we take the ACT or SAT in school, there's those specific directions that the teacher reads. There's specific ways in which you sit and how long you have to take those tests. That's a way to make sure that it's fair and consistent for everybody who's taking it. So we're going to focus the last part of this video lecture on the aptitude tests of intelligence tests and how do we measure intelligence? What do we look at today? So when we look at kind of the evolution of IQ scores, we start back all the way in like the early 1900s. The first kind of view of intelligence and intelligence scores was something called a G score. And this just means a general intelligence score. And the idea of this is that when they first created intelligence tests, they found that there was a strong correlation among skills of individuals. So if you are good in a single trait, we often find that you are good in other traits. And so people with higher general intelligences might be really good in one score, also tend to be high in other scores. And so the higher you score, the more that correlates to your height in other areas of performance of cognitive tasks. And so this general intelligence score was kind of our first way in which we put a numeric measurement onto somebody's intelligence. That since has kind of been modified in like around the 1920s. We find that that changed into what we use today, which is called an IQ score or an intelligence quotient. And what we do is that in an IQ test, in order to find out what your IQ score is, what they do is divide your mental age by your chronological age and multiply that by 100. So mental age versus chronological age. So let's say when you take that IQ test, they find that you are performing at the mental capabilities of 9-year-olds and your chronological actual age is 10. Or maybe they find that you perform at the mental age of 15, but you have the chronological age of 12. So whatever it is, you find out what the mental age is and the chronological age. You divide mental age by chronological age and you multiply by 100. Now, you want to just be smart when you think about this, rather than saying, well, how am I going to divide 9 divided by 10 and then I'm going to get a decimal and multiply that by 100? How am I going to do that on a calculator? Instead, you want to be logical, okay? If somebody has a mental age of 10 and a chronological age of 10, 10 divided by 10 times 100 is going to get you 100. 100 is going to be smack dab here in the center on this normal bell curve. That 100 represents the, I hope you are saying out loud, the mean. So the average IQ score, if a person has a mental age and a chronological age that match, their IQ score is 100, which is the average IQ score. Now, if somebody's mental age is lower than their chronological age, do you think they are going to perform below the norm or above the norm? Again, if their mental age is below their chronological age, are they going to perform below average or above average? I hope you are saying below average. So we are going to look for a number that is lower than 100. If somebody's mental age is higher than their chronological age, I hope that you say we will look for a number that is higher than 100. So just like we learned in Unit 0, when we apply data to a bell curve, right smack dab in the center always goes that mean or that average. And then in order to plot, we have to add or subtract the, hope you say it out loud, the standard deviation. And that standard deviation tells us how far spread that data is. A higher standard deviation, the more far spread; smaller standard deviation, the closer that data is together. So on an IQ test, the average or mean is 100 and the standard deviation is 15. Therefore, we should be able to plot 3 standard deviations above the mean, 3 standard deviations below the mean. We also should, from our knowledge of Unit 0, be able to draw some conclusions, i.e., 68% of the population have an IQ between 85 and 115. 95% of the population have an IQ between 70 and 130. And 99% of the population have an IQ between 55 and 145. So those 68, 95, 99% still are the same exact as they were in Unit 0. The only thing that's changed is the mean and standard deviation that we apply down here. So again, a mental age and chronological age that are exactly the same, you're going to have an IQ right smack dab in the center of 100, which is, again, the mean, the average score. When your mental age is higher than your chronological age, you're going to be higher. When your mental age is lower than your chronological age, you're going to be lower. So this is more what we look at today and what we're going to be able to, what you need to be able to calculate. One last thing that we have found with intelligence tests that will bring us through through today is that we have found that we need to re-standardize these tests periodically. So every, few years or so, we have found that we need to re-standardize it, meaning we need to give it to the population, and then we need to make sure that every score that's received after that is compared to that standardized population that I just took. One of the reasons why this is so important is because of something called the Flynn Effect. And the Flynn Effect, as you can see here on the chart, has found that IQ scores have actually grown over the past 50 years. On average, according to the Flynn Effect, the IQ scores of the average American has risen 3 points per decade. So an average person in 1929 would have an IQ score today of a 76. So we need to make sure that we re-standardize so that we bring that 100 to that average of the group today that are being measured on IQ. We don't want to compare somebody's IQ today to a standardized group from the 1920s. We want to make sure that we are comparing the current person to a standardized group of other current people at that age at that time. Some of the reasons why IQs have risen over time, some of the things that we think is that there's better healthcare today than there was 50, 100 years ago. There's more access to education, whether that be like in the public education system or even think about educational television that we have access to. The family size is lessening, indicating that the parents have more time individually for those children. We have higher living standards. We have better access to food. And those things all add into and account for this rise in our intelligence. Because IQ is not all genetic. It's not all nature. It also has that component of nurture, that when we are void of healthcare and education and proper nutrition, that's all going to negatively impact our IQ score. So naturally, if we have better access to those things, that's going to raise our IQ score overall as a community. That's where we're going to end today. In our next video lecture, we're going to talk about what are some of the negatives of these IQ testing, what are some bad things that come from utilizing these, as well as what are other theories of intelligence, and is intelligence an end-all be-all? So stay tuned for our next video lecture.